I've been looking for a theory that answers everything. I can't help it. I feel compelled. But I don't feel compelled to pursue what the method I used to do that can teach me about predicting prime numbers. I'll bet it is better than your method, but I'm still not compelled. In my search, I've tried many approaches. Usually, they start as vague ideas that I work on and flesh out into something more understandable as I go along. My ideas begin more as notions. They become something usually that I can depict in 2 dimensions. Once I can visualize them that way, I can make progress. Mostly, I can dismiss them. Naturally, I am onto something now. It cannot be so easily dismissed as many of the ideas I've come up with in the past. It has its origins in an approach that wasn't quite right, and I knew it. But it also seemed like I was barking up the right tree. I had to develop some things and give up some things, but I didn't have to throw the whole idea out. I started with the idea that space-time came in layers. I imagined the concept as evolving in lines that surround a central circle, a sphere in 3 dimensions. I could imagine it being able to go through itself and still maintain some story about the information of the atom because the story was being told in the arc of the line, not the components of the line. It therefore didn't matter what happened to the components when the lines passed through each other as long as the arcs remained true. I imagined that the shape of the central circle could be other than a circle, that as it became more of an ellipse it might influence the space-times of the other atoms to go around it or not, in some relation. I reasoned that other atoms were just like this atom. Space-time, other atoms' space-times, are what moves, not essentially the locus of the atom. The shape of an atom, where it critically meets another atom's layers of space-time, affects whether that space-time is likely to move around it in one direction or another, potentially lessening the number of space-time layers between our atom and the emitting atom. I say things move in relation that way. Shape would be related to temperature as well, only an ellipse wouldn't be the shape responsible. You can imagine partial movement, equivalent to something more like vibration, causing temperature. Something that doesn't commit to being a particular shape, like an ellipse or anything else does. Maybe the equivalent of the shape trying to be an ellipse in many directions at once. I decided to use math. I literally made the model for this idea out of numbers. Prime numbers turned out to be important. I needed something I could use within numbers that could explain space-time as I envisioned it. It had to exist forever. It had to look like it occurred regularly enough, even if the actual occurrences were random. I had reason for envisioning it this way. I had experiment. Those experiments were based around scale models I made of the furniture from the Jewish temple. I constructed models of not only the ark, but of the incense altar, table of showbread, and the candlestick. I put a prospecting device I used that detects for tuned frequencies on the ark. I tuned it to the frequency of the paint I painted all of the scale model furniture with. The experiment revealed concentric circles around my setup, beginning just outside of the farthest pieces. I placed them relative to each other in the same position as their namesakes were placed in the temple. Before I developed the model, I had no idea how I could derive those circular signal lines. I needed something that related to how an observer would understand a single point of observation. It needed to respect that no matter the distance, while still saying something about expansion. I needed it to expand over space-time and reflect what was happening in the math while also remaining constrained in important ways. I compared 2 Excel spreadsheet tables, one composed of all of the integers, the other composed of only the prime numbers. I put both tables together the same way. Both tables are based upon division. Both run along a horizontal 1 axis. Both tables keep the same integrity regarding denominators. There are enough similarities, even though these tables are fundamentally composed of different sorts of numbers, that I could compare them. Because both tables are based upon division, I could put the same operations to work in both. Before long, I settled upon a fundamental operation. I found that I could divide numbers on the left side of my tables by numbers to the right of them. It made sense because of the way the tables were constructed. The basic operation involved dividing by the number diagonally down from the given number on the left, which I was operating on. When I put the operation to use in the integers table, I came up with a certain result in a certain place within the same table. As I developed this according to the rank of the divisor, I could see a pattern. When I tried to do that with the primes table, I could not define the result in that table. It was not like the result was moved to another place in that table. It wasn't there. I could, however, find it within the integers table. The results from the primes table show up as the red numbers in the integers table above. The outline boxes aren't relevant here, even though some of them are red. I'm sorry if you are colorblind. Finding the result of the primes table for that first operation within the integers table allowed me to see how the prime numbers are represented within the integers table as a transform. The prime numbers are represented there as they appear in a pattern which develops in the integers table along the one-axis. They develop by columns, but those columns respect the spacing inherent to the primes. The transform did appreciate the new primes by column, but only when I extended the calculation. I had to define the columns beyond the first column in each table as ranks. I could label them first, second, third ranks, and so forth. Someone from Reddit advised me to approach things this way. I like their advice. It makes sense to standardize things so that they can be enjoyed at a glance. More than anything, I guess, the transform took the idea of the primes as they were in the primes table and distributed them over the integers table perpendicular to the order of called occurrence. You can see that the order of this is interesting. We will use it as we proceed. When I compared the transform, I was able to see certain characteristics of the prime numbers that came up because of the constraints I had placed the numbers into. One of those was that the transform pattern had a respect for the number 1 at its beginning. The first transformed prime of each column is defined according to its relationship to the one-axis of the integers table. Sometimes you see two occurrences when you look at the plots, but that only happens at the beginning. When you see two numbers above 1 in a column at the beginning, they are of different ranks. Once the ranks develop, one number above the one-axis seems to be the rule. It develops in a manner that accounts for expansion, there being greater meaning available at each distant point along the one-axis from 0. They come from a comparison from a different table that also has that one-axis construction. It splits the primes table. Dividing by ranks, there is this one comparison. Understanding the role of 1 in constructing the next prime, it might mean something too. I split the primes table, theoretically, along that axis. It corresponds to the 2 axis of the integers table, but our attention is upon the primes table. We can split it. The transform pattern only appeared at one intersection of what I was comparing, that of division, where regardless of what was going on in the primes table, the result would always be in the integers table. I could use the way that the primes respected the one axis in that transform in order to form a principle in the other intersection where I was seeing if I could construct new primes as well. My table's other point of contact was along that route, where the relevant figures I would work with were all within the field of the primes table. I could see that evaluator would change as I went along. It only started out as 1. I was approaching the problem as if I had to create the numbers, and to continue every so often juggling between the tables, the next number had to be prime. I was working the same scene in the primes table, but the other side of it, when I considered prime number invention. I could change my perspective depending upon what might give me an edge. I used that fascination with 1 to extract a principle when I looked at the primes table, and also considered the integers table, just juggle again. Imagine how excited I was when this looked like it worked. The first few prime numbers are obvious because they actually use the number 1 as the representation of 1. For instance, the next prime cannot be 4 in the primes table because 2 divided by 2, 4 over 2 making it 2 divided by 2, is 1. The result has to be less than that, just like it is when we evaluate numbers on the other side of this setup. So we have to try the next number. When we are looking for a new prime after the first few, we are looking for a number that satisfies whatever the version of 1 is in the relevant rank. We have to find the first number that is less than that. Just like all of our prime columns in the transform have an instance that begins their column which hangs above 1. We have to determine what that representation of 1 is for a rank. The rank depends upon which hypothetically new number we are evaluating. That tells us which prime column, as we have developed them, in the integers table we need to be looking at. As far as that part goes, these are tables. They line up pretty well, even if not immediately under each other. We can, for a while, use an evaluator in the integers table to determine which numbers will be prime. The evaluator matches what we should operate with in the primes table to determine the next prime. We can see this works because we know from outside data which numbers are prime. It works until the way we have to work out the evaluator introduces choice. We use 1 divided by whatever number in the column of the integers table because our 1-axis is infinite. And we are making that much choice to begin with, and no column's number will get outside of that. We'll get into the actual calculations at the end. At first, there was enough information that I could tell right away what the answers were, even if it did take math. But soon, I didn't know where to begin. I had too much information. There was noise which represented spaces between the correct choices. It happened because of how the table represents expansion. It was easy to understand the noise at first. It wasn't so easy once the complexity got beyond the first few numbers. When I first discovered the choice, I wasn't sure if I should continue. Then I realized I needed that randomness. I needed it to match real-world observations. If what I wanted it to match was real, it had to have that, since I believed that prime numbers had something to do with the phenomenon I observed. It needed to expand. It would explain isotopes. It would explain temperature and movement. Instead of visualizing a circle, I had to embrace what 0 meant to the shape. It's a different way of looking at the same idea, but one which more credibly aligns the numbers we are used to understand how they convey these things. You just have to do a thought experiment. What is 0 over 0? It isn't 0 and it isn't 1. Without constraint, you cannot ever imagine the same things going on in the first 0 as are going on in the second. But we sort of understand constraints when it comes to this. We can make 0 over 0 equal an ellipse or something more complicated. It has implications upon local space-time, which will disappear in expansion. Incidentally, dark matter? Anybody? Look how this model demands it. There will be all of those outer layers of space-time which have gravitational effect and that are not pointed directly at what drove them. They essentially point at nothing. There wouldn't be that much antimatter in the universe because there are no negative prime numbers either. Speaking of matter or mass, there is more to this. When we visualize the proton according to the arc model, adding another proton doesn't mean adding another arc. It means adding another set of the two most outward sets of furniture, the candlestick and the table of showbread. If we take that as God saying anything about this, that probably means something about adding a neutron. That would explain how neutrons are found where they are. There will probably be some arguments about isotopes. That's too much to get into here. Clearly, the model also applies to thought, especially where common junctions cause sharing and how the arc model suggests many spacetimes, if we can call it that when we say this refers to thought, are taking place. With the atom, that number is limited to what can stay together in reality. In the brain, it is limited to whether the processes building up your brain are allowed to continue or not. Because in thought, there is no such numerical limitation, unless it is of the ultra huge variety. We don't wake up unable to process complex things like visual stimuli. You got to figure that with thought, the fact that you can choose other than primes to base your models on will matter. They won't pass the test that the primes will. Maybe they will be stronger, like emotions can be strong. Maybe such a thing suggests certain cycles. I figured that if the whole of observable space surrounding a central point can be understood spherically, then taking that to some sort of limit and seeing space-time along a single axis of observation might look something like how I have constrained my tables. We can get at how prime numbers are involved in that and extrapolate their influence as well as that of the alternatives our method offers us over the sphere which is created when we integrate the whole thing. The math to understand how all of this works out seems pretty complicated. Maybe we can understand some basic principles that will work to, say, help us arrange groups in the consolidation. It is the freedom of movement provided by choice that allows the sphere to change shape. It has freedom within bounds. One bound easily understood is how primes are defined. Other numbers used in their place will only appear the same until that test. It is how all of those actual measurements work out in the instant that causes the shape. Energy is what affects that. I posit that has an effect upon the space-times generated by other such central points of importance. Whatever layers they are made of are encouraged to go around a certain way or not. Something about that may indeed have to do with temperature and movement. It explains gravity. It may explain entropy, and that there is at the very least a reversion to the primes over other numbers. The transform we've been looking at could be considered some kind of coiled spring as well, which might also reinforce entropy. You expect these things to remain consistent so that they don't deviate from the arrow of time. I did this and I still found randomness. I had an easy time plotting where the next primes were because I wasn't using this method to discover them. I knew what they were. If I had, though, at first they would have been easy to find. They have to do with discoveries I'm trying to make in the primes table, or just the other side of the 2 axis that forms in the integers table. I hung my prime discovery areas that low, all the way to that 2 axis in the integers table, but still I'm not sure if that is correct. The numbers I am looking for that clue me into the meaning of 1 in this rank appear in the relevant columns of the integers table, in line with the way the primes occur. At first, there weren't so many choices. Picking the right thing was easy. That changes quickly. Or what I want to say is there is something about randomness that this method does cut down. I was not able to use the idea to prove anything. I did see something when I plotted the location of the prime numbers in the ranks, however, when I was plotting them as if I discovered them. I can discover them because there is a perpetual 1 axis which I can choose to help me because our 1 axis is actually put together to be a singular axis of observation. So 1 divided by whatever number we are considering in our column in the integers table suddenly equals the number we are considering in the primes table divided by the next equality to 1. It's pretty amazing how things all line up. Even if you don't think you will find it, you will discover that with the simplest math you can. The equivalency to the confirming number in the integers table, the one equal to the pursuit of 1 in the primes table if we are looking to create a new prime, seems to occur with some sort of regularity within the columns of the integers table. They do appear predictably within columns there. There is a spacing which may honor potential locations of the primes, but we don't know where they will appear within the columns when we are faced with predicting. There is some idea of equality spread across the columns in the spans we are looking. It appears there are undiscovered principles waiting to fill out some spots, taking up the probability that the next prime could reside there. It is something like context. This model is potentially saying that if you can understand the context, you can predict the next prime, at least to a point where humans again have to be involved. But at that point, it should be easy for them. Look how the context eliminates so many choices. If so, and there is truly something going on about the equality in this particular geometry, especially this section of it, then it may narrow down the search for the next prime enough to make it a better guess. I don't know if it holds up or not, but I wanted to mention it. It may be important. You can see that I did this in order to hang a world order on it, pun intended, with the layers I saw in the experiment with the arc model. I did not do it to find a way to discover the next prime.